Let's now understand one of the most important tools that make file handling random file access possible, that is seekg and seekp functions. These two functions are used to move the internal file pointers that controls where the next read or write operation will take place. So the term G in seekg function stands for get, and it is used for input streams like if stream to control where data is read from. Similarly, P in seekp function stands for put, and it is used with output streams like off stream to control where the data is written to. The first and simplest form of these functions looks like seekg, maybe long position and one argument long position, or seekp with position one argument. So this version moves the file pointer to an absolute byte position inside the file. So let's look at this example. If stream fin object, and for off stream we have created f out object. Then we have used file opening routines. When we write fin.seekg30, we are telling the program move the read pointer to the 30th byte in the file. That means the next read operation will begin from that exact byte position instead of starting from the beginning of the file. Similarly, fout.seekp30 moves the write pointer to the 30th byte. So the next write operation will start exactly there. So this technique gives us direct access to any specific location in the file without having to read all the previous data sequentially. So you can think of it like skipping directly to a chapter in a book instead of flipping through all the earlier pages. So this is extremely useful when dealing with structured data files. For example, when we store a list of fixed size records such as student objects or employee data, we can calculate the exact byte location of any record and jump right to it using seekg or seekp. So seekg moves the get pointer for reading and seekp moves the put pointer for writing. And in this first form, both functions move to absolute byte position in the file. Now let's move to the second form of these functions, one that provides much more flexibility by allowing us to move the pointer relative to a reference point, unlike absolute byte position. So this forms look like seekg with two arguments now. One is an offset and second one is an origin. Here offset tells us how many bytes to move. Origin specifies from where that movement begins. In other words, the pointer's new position is determined by taking the origin point and then adding or subtracting the offset value. So C++ defines three possible origin constants. Number one is with beg, that is the beginning of the file. Second one is cur, meaning the current position of the file pointer, and finally end for the end of the file. So let's understand it through few simple examples. For example, let's see the first one, fin.seekg with two arguments 10, and in the second argument we have supplied the first origin constant, that is the beginning one. So this means move the get pointer 10 bytes from the beginning of the file. Second one with first argument as -5 and then end marker means move 5 bytes backwards from the end of the file. And finally, for the cur, that is current position of the file pointer, this means move 20 bytes forward from the current position of the get pointer. So the same logic applies to seekp versions for output streams, allowing you to position the right pointer anywhere in the file relative to the beginning, current position or end, like we have done with the seekg. So this version of seekg and seekp gives us a true random access control. We can move forward or backward through a file very easily. So this is extremely useful when we need to skip headers or metadata at the start of the file, or we want to jump to the specific record, or to go backward to reread or modify something. So together of these two forms make it possible to navigate through the file very easily. So now we as we have learned how to move the file pointers using seekg and seekp, let's see how we can know exactly where these pointers are at any moment. So C++ provides two very useful functions for this purpose, tellg and tellp. Just like before, G stands for get and P stands for put. Tellg tells us the current position of the get pointer in an input stream, while tellp tells us the current position of the put pointer in an output stream. When we run this code, we will see that tellg reports the exact byte position in the file each time, 0 at the beginning, 10 after moving forward by 10 bytes, and the number close to the total file size -5 after the final seek. Similarly, tellp works for the output file streams, showing where the next write operation will take place. So these two functions are extremely useful when performing random access file operations. Let's now see in action how the write pointer or the put pointer moves inside a file, and we will also observe how tellp reports its position after writing. Here is a program that writes the text bscf19m001, that is a roll number, into the file. After writing, the put pointer is at the end, just past the last written character. Tellp reports that position, so it tells us how many bytes have been written so far. Then we write seekp function with 6 and beginning mode, and that function moves the write pointer to the 6th byte from the beginning of the file. At that point, when we write A, the character at the position 6 is overwritten by A, showing that we can directly modify any part of the file by moving the pointer first. So this is the essence of random access. Here we again open the file for output and write bscf19m002. The tellp call gives us the current position after writing these characters, so it is right at the end of what we just wrote. Now instead of moving from the beginning, we use iOS and that current mode, which means move relative to the current position. So the first argument we have written 3, that means move the pointer 3 bytes forward from where it was, and then the program writes bscf19a002 starting there. This way we can skip or leave gaps intentionally in file, for instance to reserve space for future updates or structured records. Finally, the third example adds a twist by using that end mode. Here the program writes bscf19m002 and then that underscore and asterisk into the file. Now notice the line file.seekg with -1 and that ending constant. So it moves the get pointer 1 byte before the end of the file, but since we are still using the same file stream object, this effectively sets the position for writing to just before the end. Then we write fall 2019 at that location, meaning our new content overwrites the file from near the end. So this shows us how seekg and seekp can even work relative to the end of the file, showing us to append or modify the tail portion of the file very efficiently. So in summary, tellp tells us know where we are, while seekp let us go wherever we want inside the file. Now let's look at a very interesting and practical example, that is how we can directly access a particular person's record from a file without reading all records one by one. So this is possible using random access again with seekg function. So this class only has one data member, age, and two functions, get data to input a person's age and show data to display it. So in real world program, the class might include name, ID or address, but for simplicity we have just added one integer here. Next, in the main function, we want to read a particular record from the binary file. So we open the file persons.txt in binary mode. Because we previously wrote objects onto it using binary output, opening a binary mode ensures that data is read exactly as it was stored without any text conversions. So this line seekg jumps to the end of the file. Tellg function tells us the position of the pointer in the bytes, effectively giving us a final total size of the file. Then we divide that size by size of function that gives us the number of persons objects stored in the file. Next, we ask the user which record they want. Suppose the user entered 3. So then the program calculates the byte offset as that 3 minus 1 into size of object. That gives us the position of the third record. So seekg position statement moves the read pointer directly to that location in the file, skipping all the earlier records instantly. Finally, we read the object using that read function and display the relevant data. So the read function brings one full person object from that exact position into the memory, and the show function prints the result on the screen. So this approach lets us fetch any record directly, whether it is first, whether it is fifth, whether it is 100th, all in constant time regardless of the file size. So this is how databases and index based systems achieve efficiency. So they rely on binary file access, random access using seekg and tellg functions.